Hello to everyone joining us this morning. This is Shannon Dabercow. I'm our Global Product Manager for our Data and Analytics offering. I also have with me Audrey Denis, who is our Senior Business Analyst who supports our analytics team. And a little background on what we're going to talk today before I go into our team. We are excited to show you today our products and service offering for analytics. And the idea is that we're going to start off with going through what we hear as common agency challenges with the data that they have, some solutions that we've addressed these issues with, and a demonstration of how we can support that through our ridership analytics, our service quality analytics, and our custom analytics. But most importantly, we want to hear from you on how we can improve that. So a bit about our team. We have a Center of Excellence dedicated to analytics. Cubic generates a ton of data. So we have a team devoted to putting that data to work. And what I mean by a ton of data is over 50 million passenger transactions each day globally. So our analytics team has been providing data science services to agencies, for example, transfer point optimization, queue analysis for gate place, as well as supporting innovation initiatives for over 5 years with a network of expertise that we use for collaboration. And what we do is we combine a combination of products and services, which includes our data management analytics platform, which we're excited to show you today. But most importantly, from this webinar, we want to hear from you about how we can improve on what we have. So let's start with some of the challenges that we've heard. So prior to Cubic, I spent the better part of a decade doing data consulting with Deloitte, and across industries, there's significantly more data, tools, and techniques over time, but the sense of making sense of it remains the key challenge. Specifically in transportation, we've seen more frequent pings of geolocation with RTPI and new IoT data sets and sensors, in addition to traditional revenue collection. And some of these pain points that you see here in this Venn diagram are not necessarily applicable to the agency size because every agency is on their own data journey. But more often than not, we hear small size agencies really want to develop KPIs and incorporate data into their decision making, but face hurdles in terms of budget, size, staff, and data quality, often having one person wear multiple hats. For larger agencies, they tend to have some KPIs established since they can sometimes have internal data teams to do reporting and KPIs with moving their focus more to advanced analytics. But across all agencies, we find challenges making data shared across the organization and integrated across different data sets. So breaking down those silos. There's often a struggle to make actionable insights with a vast amount of data. So getting the data turned into insights and information to the right person at the right time. And additionally, with a world with more data, data privacy is always front of mind when we think about data analytics and data management. But regardless of where you are on your journey, there's more data becoming available to make sense of, and that's not always easy. So what we like to think about in terms of a vision is really what does data offer the transportation and transit community? And first and foremost, you can't manage what you can't measure. But when we think about what the reality could look like with integrated data across all the data sources in a city and shared among all city stakeholders, is having data insights to improve passenger experience, service delivery, and your strategic citywide decisions and policies. So agencies can use passenger movement insights to align schedules and asset allocation to where customers are going, with advanced analytics to infer destination and link trips for optimization across the broader multimodal network. City stakeholders can not only monitor the complex interdependent objectives around ridership, service quality, and even congestion, but also have the ability to influence passengers' travel choices based on insights into their habit and demand. For example, personalized nudges to influence a passenger by arming them with the right information at the right time to mitigate a service disruption. Or bringing in different modes of micro-mobility options to start having a unified view to enable agencies to evaluate equity and distribution. But that's kind of the 1,000-foot view. But let's come back down to reality about what the day-to-day would look like of taking advantage of your data with some of the capabilities that we're going to demonstrate. So now I'm going to turn it over to Audrey, who's going to go through the demonstration. So Audrey, over to you.
Great. So I'm going to walk us through our data management and analytics platform. A couple of the capabilities that we're going to walk through are Ridership Analytics, which is an overview of ridership volumes and movement through the network. Service Quality Analytics, which gives us a sense of how routes are performing where you have trip delays or other service quality challenges. And then a custom analytics module, which took about 2 weeks for our team to work on and is an option for any agency that has data that they want to visualize or questions that they're asking that aren't directly answered by some of our other data analytics modules that already exist, like ridership and service quality. And so for this particular one, we took a bunch of open public data APIs in the city of Barcelona and created over a 2-week sprint a picture of mobility in the city of Barcelona. We'll also walk through the platform, which has a variety of these different modules and platform features, and is configurable to any type of data. So we can pull in fare collection data, automatic passenger counters, CAT AVL, and other arrivals data, but then pulling in a broader picture of mobility, coming to micromobility, active modes of transportation, pulling in IoT sensors and traffic data to really bring every different data asset into a single picture so that all users can access the same unified contextualized information and share those insights across the organization. We also have organizational and role-based access. So for an authority that has several agencies underneath it, you can have access to all of those agencies' data and make that data available just to the agency to whom it's relevant to. For a role, we know that executives have certain jobs and they want to be able to keep their finger on the pulse of the network, but they might not need to dig into the data quite as much as an analyst. And so there are different modules and platform features that are available and configurable based on role-based access. So without further ado, we can go ahead and hop into the demo. So this is our data management and analytics platform homepage, and all of the analytics modules and platform features that you subscribe to will be available on this homepage. So we have the ridership and service quality analytics modules, and then we also have platform features. So for example, the de-identification engine. Shannon talked to us about how privacy is always front of mind for agencies. We know that particularly as traffic and transportation agencies are looking to support open data initiatives and make data available through APIs, that there is the challenge that comes with that of making sure that you're not releasing private, sensitive, or PII data. And so we've developed a tool, our de-identification engine, that hashes any PII and other sensitive data to make sure that it's completely clean and ready to go when you publish that through an API. So you don't have to worry about it becoming repersonalized or any of that information putting any of your passengers at risk. So we can start with our ridership analytics module. This provides us with an overview of movement through the network, where people are starting, where people are going, the routes that they're most frequently riding, and then also gets into excess wait times and some of the overall quality of the rider experience. We can start with the ridership overview. This is a dashboard that allows an executive user, planning users, operators to keep their finger on the pulse of the network. In this top visual, we can see ridership by actual time, the time of day, and then the day of the week. We can see ridership by route down here and ridership by origin stop to get a sense of where people are riding and where they're starting and how they're moving through the network. And all of these dashboards are configurable And we have different modes loaded in here: buses, trams, cable cars. But this could be expanded to a broader view of multimodal movement through the network. So for example, loading in bike share or scooter data, or even pedestrian, so that all of your movement through the network is captured in one picture. And this is an interactive dashboard. So for example, we can even push on the bus part of this visual, and it will down select all of the other visuals to just be for the bus. And we can also, for example, use these drop-down menus at the top to further down select the visualizations. But for example, if we were an executive user, we might notice that Route 29 has a pretty significant number of riders. And so they might ask a planning or operations user to dig a little bit deeper into that route and look at how performance is on that route. So we can go to the ridership and excess wait time trends visualization. This is giving us a heat map on the top of ridership by day of the week. More green is more riders, whereas more black is fewer riders. And on the bottom, we have excess wait time by day and service hour. And where we're more red, that's where you have more excess wait time, and where we're more green, it's less excess wait time. And this is where we've calculated the excess wait time for a passenger beyond what they were scheduled to wait. So where do you have passengers that are waiting too long for the bus or the metro as a result of schedule delays? So in particular, if we want to dig into Route 29, we can scroll down and down select the entire visualization just for Route 29. And we can see that there's actually pretty significant excess wait time throughout the service day. And for example, we can click on Thursday at the 18th service hour, which for this agency is 6 p.m. All of the service hours are configurable. We know that different agencies start their service day at certain times, so all of that can be loaded in here so that it's all consistent for the agency. But for example, we can look at 6 p.m. on Thursday and see that this excess wait time is impacting about 3,000 passengers. What this allows users to do is characterize service disruptions in terms of the number of passengers that are impacted. It allows you to more easily prioritize what routes and what times of day you might want to look for mitigating solutions, so that you make sure that the resources and the effort that is spent to improve service is going to impact the greatest number of customers. As we're doing some of that assessment of excess wait time, we can then also get into the excess wait time map. So this is providing us an overview of excess wait time by location throughout the network. It's a lot to look at with all of the different routes loaded in, but we can drill down specifically on Route 29. And then we can see that the larger bubbles indicate where there's more wait time, and the smaller bubbles is where there's less wait time. So we can see these larger bubbles are congregated in this route here and also in this route here. Just as a general note, all of the data that we've been going through is simulated, so we're not sharing anybody's private data or information. This is all clean to show the capability of data analytics. So in particular, these routes have congestion in these particular areas, and an operational user could dig in and start to consider, are these delays the result of an obstacle in the road? Is it because of maintenance challenges that are creating delays? Or is it more of routine congestion? Is it that there just happens to sort of consistently be congestion on these routes and it's hard to hit those schedule times? And that's where this power of this tool really comes in, is that you can identify challenges, glean insights, and then make sure that your operational and planning and executive users are all on the same page looking at the same data. So if an operational user highlights these challenges, determines that it's not really an operational problem, and then hand it over to planning, and planning can be looking at the exact same visualization to understand that maybe we need to change the route, we need to move it over, or perhaps we should change the schedule altogether because it's unrealistic. So in addition to being able to load in these arrivals data, GTFS has a range of capabilities that we can pull in. So for example, when we're thinking about excess wait times, what we've done in the past is also pulled in GTFS data on urban furniture, which allows us to do analysis of if you have long excess wait times, where can you be distributing urban furniture throughout the network so that people can wait in comfort. And then in addition, we can enhance our ridership analytics module with our passenger movement analytics. Passenger movement analytics gives insight into full journeys, and we have a range of different advanced analytic engines that underlie this capability that allow us to infer linked trips, so linking between different modes so that you know when a passenger has taken a bus and the metro to their final destination, as well as making inferences about their final destination. When you only have tap on only bus systems, where can you also see where people are getting off so you can understand movement through the network? And then also making inferences about the passenger, so understanding what kind of passenger they are. Is it a family or a commuter? And this allows us to enhance the picture, to have a full understanding with advanced analytics and data science inferences about the type of passengers and the movement through the network. But for this particular user, they've subscribed to both ridership and service quality. So we can click on the service quality analytics, and this is where we can start to contextualize ridership and service quality in the same picture so that we can understand how the route is performing and the people that are being impacted by that. So we'll go into a little bit of trip delay and bunching and gapping and some of those challenges. So for example, if we're to continue to do our analysis on the excess wait time on Route 29, we can look at a heat map of bunching and gapping throughout the service day and then schedule adherence. Particular to bunching and gapping, we have developed a metric to analyze how close together and then far apart buses are arriving so that you can get a sense of severity of bunching and gapping. And that's displayed in a heat map on the bottom. And then on the top, we have the schedule delay that that's causing. So again, we can down select to just one route for Route 29. And then we can see that there's somewhat significant bunching and gapping throughout the service day, but that there's not too many service delays that are being caused as a result. We can dig a little bit deeper into trip delays, though, to look at what the overall distribution of trip delays looks like. This is showing us a multimodal view of trip delays throughout the network. And this is a pretty standard distribution that we see, although since this is generated data, the range is quite large. But we don't really want to see buses leaving too early without people, or any form of transportation leaving too early without people. And so we tend to see more of a distribution across lateness rather than early. And then this is giving us a breakdown throughout the service day so that we can understand if delays are concentrated during a particular period, like the morning and afternoon rush hour. We can look at it specifically just for Route 29. And we can see that there's actually pretty significant service delays, and those are throughout the day. So as a result, we might make the conclusion that the schedule is somewhat unrealistic. It's not that, but this route is facing an unrealistic schedule that they can't keep to, but perhaps perhaps requires realignment of the schedule or thinking through changing the route a little bit to make it a little bit more realistic. We also have loaded in user data dictionaries. So for any of the terms that you're seeing, so for example, service day, there is a definition there for you. And in addition, you could search. So for excess wait time, a definition comes up right away. And we also have user guides. So for example, if you want to understand a little bit more about the bunching and gapping and exactly what that range of the score that we've assigned means, you can go into the bunching and gapping part of the how-to and get a better sense. But the overall how-to gives a understanding of how to navigate through the tool, as well as how to select the reports that are going to be the most relevant to the questions that you're asking. We also have the power to create our own reports. So a user can delve in to create their own reports that allows them to access the power of the data model that's underlying all of the pre-generated visualizations that are available to users. So for example, we can click on this bar chart with a line. And then this is also where a user has the power to combine both the ridership and service quality. So for example, what we can do is put the service hour in the shared access, and then we can drop schedule deviation into the column values so that we can look at what is our service performance looking like, and then we can put our unlinked passenger trips into the line value. And we have the power to make these averages or sums. So I'm going to do an average for both. And then we can see our distribution throughout the service day for ridership compared to our trip delays. And then a user can start to identify when you have peak ridership, so when you want to be focusing on addressing some of your service delays versus when ridership might be falling. And we know that agencies tend to do these reports multiple times, perhaps quarterly or even monthly. And so you have the ability to save this report. So we can say demo 1, and then you'll be able to access that again by using My Reports. So we can see that demo 3 is available there, and then that we can open it again so that you can return to these reports and refresh them with new data. So that's the power of being able to dig into the tool yourself. And then we can wrap it up with our Barcelona Smart City Analytics module. And this was a 2-week sprint to give a picture of mobility in the city of Barcelona. And our team of data scientists, data engineers, data analysts pulled together all of the different public APIs of data in the city of Barcelona to try to pull together a multimodal picture of mobility there. So we can start by looking at bike share availability. We know that as micromobility and active modes of transit become more popular, that bike shared is a mode of transportation that people are more and more relying on for their commutes and to get across cities. So we've loaded in all of the availability of bikes across the city of Barcelona. So where we have red dots, that's indicating there are fewer bikes, versus where we have green green dots is where there are more bikes available. And a planning user could use this to understand flows through the network in terms of bikes and usage. So we can see at the 6 a.m. service hour, before everyone's left for work, that there are more bikes available in the outskirts of the city and then in this central corridor. But if we look at 11 a.m. after people have left for work, we can see that a lot of the bikes have left the outskirts of the city and the central corridor and moved to be more clustered into the center of the city, where people have brought bikes to go to work. And a planning user can then analyze the distribution of bikes, looking at those stations that have very few bikes that are available, and choose those as candidates for potential capacity expansion. So as a user, you can see that people are definitely using this for their commute. This is a mode of transportation that they're reliant on. And then there are strategic ways to expand that capacity to make sure that people are able to take bike share when they want to. And we've also loaded in slot availability, which, as you might imagine, is the inverse of what we're looking at. But if you're a planning user, you want to make sure that if you're expanding bikes at your starting locations, that you're also expanding the slots available at your final destination to make sure that people can park the slots when you've expanded that, or park the bikes in slots when you've expanded that capacity. We also have Twitter sentiment analysis. So we've connected our platform to the TMB info, which is the main Twitter handle for the city of Barcelona, to tweet out any disruptions on their public transportation. And we are pulling any retweets or interaction with that handle, and then applying machine learning and advanced analytics to assign sentiment scores. So identifying when there might be negative tweets coming across. And this allows an operational user to identify service disruptions or challenges that might be arising in the network before they might be able to identify them through natural or organic means. So for example, we can down select to just negative tweets. And then in the bottom here, we can see that Juan is telling us that there's 24-minute delays on line 1, and is that what's going on with that? And so an operational user would then be able to dig a little bit deeper and determine if those were delays that were expected, or if those delays were out of the ordinary, and start to take any mitigating solutions. And finally, we can look at a few visualizations that are overlaying bus arrivals and traffic. So for example, we know that traffic can be a big impact on bus arrival times. And so it's helpful to have all of that in a single picture. So we've pulled the traffic and the bus arrivals APIs. Here we go. So this is showing us bus arrivals, so when the next bus will be arriving, which comes from the iBus API in Barcelona, and then overlaid with traffic data. And it's a lot to look at everything all together, but we can down select to just a particular line. So for example, if we look at just line 113, we can see these bubbles when they're larger, showing us when there's longer time for them to arrive. When they're smaller, it's a little bit less time. So 36 minutes versus 13 versus 9 minutes. And then the traffic is displayed with green, red, and orange. So for example, we can see that we've got a 36-minute wait, and that is on a route that has particular significant amount of traffic, which may suggest that traffic might be causing some service disruptions. And this would all be available through our congestion analytics and our service quality analytics, overlaying where you have congestion and how that's impacting the performance in the network. In addition to pulling in bus arrivals with traffic, we can also look at traffic incidents in the network. So we've classified incidents that may be arising across a variety of different incident severity. So we've classified incidents across minor, major, and critical, and are mapping them in real time on a map overlaid with traffic, so you can understand how traffic may be impacted by incidents. So for example, we can see that we have a cluster of critical incidents on this route that has pretty severe traffic. So as a traffic engineer, you can start to identify those routes that you want to designate for prioritized resources to clear, so that you can make sure that you're getting traffic free flowing and moving again. And if you want to be able to look at those traffic flows in real time, you can then come over to our camera view and access where you might be able to see traffic building up, or any incidents that are arising, and then traffic as it clears up when those are mitigated. And that just gives you a little bit of a taste of what we've put into our demo. We only had time today to go through our ridership analytics, service quality, and our custom analytics module, but there's a range of different tools here that are available, and we'd love to get your opinion and feedback on the top 3 that seem to jump out at you. And now I'll hand it back over to Shannon.
Great, thanks, Audrey. So our core subscription is often bundled with an upgrade or a new cubic fare collection, revenue collection, RTPI, or surface transportation solution, but it also can be a standalone subscription to support any fare, fleet, or absolutely any transportation data feed or use case. It's a service offering with modular features so that you can pick and choose what is relevant to you and also subscribe in the future to features that become relevant. So there's two tiers, but you can pick whatever features you want to bundle. It's a foundational framework to consolidate insights, easily accessible and actionable, with the analytics modules ready to also with advanced analytics capabilities like destination inference, traveler insights, as well as availability of other services like our to create a custom analytics module. If there's something here that you want to do that's not here, something we showed you today. And in addition, what we find some agencies particularly attractive is that we can provide a pilot proof of concept of the platform with our service delivery approach, along with our analytics innovation workshop, which we've outlined on the next slide, which collaboratively gets the business units together across the group to identify priority use cases to strategically enhance this platform offering as it evolves over time. So that analytics innovation workshop, Audrey, if you could go to the next slide, it just brings everyone across a cross-functional group of people across the organization to help get everyone up and moving and agreement on what kind of their key challenges and insights would be, so that we can put that in a roadmap tailored to how you want to kind of strategically invest in analytics and data management over time. It's really kind of the first step in that data journey. So without any further ado, we appreciate your time today, and please do not hesitate to reach out to us. We appreciate all the engagement throughout this webinar, and you can always reach out to us if you have any questions. And thank you for your time.